Run length encoding is a very simple form of lossless data compression in which runs data as a single value in count and not as the original data. The good thing about run length encoding is that it is quite simple for computers to understand. On the other hand, while it might be simple, we won't know the immediate file storage as it is compressed, and it doesn't really guarantee any storage saving. Here we have a 4x4 bitmap grid, and the key, where green is represented by 00, red is represented by 01, cyan is represented by 1, 0, and yellow is represented by 1 and 1. So each color has a 2-bit value. Since one color represents one grid or one square, and there are 4 squares per rows, that means that one row equals 8 bits, which is 1 byte. Since there are 4 of them, there's going to be another one, and another one, and another one, which is going to be 4 bytes, which is the storage space that this bitmap will take. Let me fill in the bitmap. The computer will detect each square. So for the first square, what the computer will do is that it will detect the color, which is green, and there's only one of it. And what's green in binary, represented by this key? It's 00. The computer represents it by doing a bracket 1, 00, as there's only one green, one box of green, and that's the binary number of it. Then what we have is a 1, 2, 3, and 4 yellow, which is 1, 1 box, and we have to do the same for the rest of it. So this is the run length encoding code, which is sent as an encrypted file for lossless compression with the key, so the computer can regenerate this after decompressing it. So let's try it out, okay? So I'll remove all the boxes. So let's start from the top. There's 1, 0, 0. So there's one box of 0, 0, and I'm looking at the key, and 0, 0 is green. Then what we have is 4 11s. So I'm going to count to 4. 1, 2, 3. That's the end of it. So you have to go down to the next row. 4. Next up, we have 3 squares of 01s, and by checking the key, it's red. Then we have 3 blues, as 1, 0 is blue, then 1 green, and 4 reds at the bottom. So I'll just complete that. And so that's the decompressed file that the computer regenerated. And as I said before, the whole 4 rows take up 4 bytes. What this does though, what the computer does is that there's 1 green, then there's 4 yellows, then there's 3 reds, then 3 blues, 1 green, and 4 reds. And one character is actually represented by these numbers, or binary keys. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Since one character takes 2 bits, what we do is times everything by 2. So we have 24 bits in this type of run length code that we can read. So this has 24 bits right here. Let me move this down. And if you divide this by 8, you actually get 3 bytes. So the whole thing before, the uncompressed file, the original file, was 4 bytes. But we compressed it to 3 bytes. So we actually saved 1 byte of it. And that's Run Length Encoding. Here is a RLE compression coded in Python on replit.com. And so I'll explain how this works. So x is a variable which is storing a string which contains a binary number. So as I said before, 1 1 was yellow, 0 0 I think it was red, etc. This basically represents a pixel or an image. Then we have the counter, and y is an empty list and value is set to the first value of x. Then this is where the interesting bit starts. In the for loop, which repeats the number of time there are characters in x, if these two are equal, as Run Length Encoding works in pairs, then the counter adds to 1, as there's 2 of them, and it sets the value to the next character as they work in pairs. So these two compare, then these two compare, etc. Since these two are equal, the loop repeats again, and then it goes into the next one where they're not equal. So the previous stored 1 and 1 is added. This means that the y list will say that there are 2 1s before switching up into a different character, and then the counter and the value resets, and this loop will repeat until the end of it, and it will print the y list. So let's run it. So here we go. There are 2 1s, yep, 2 0s right here, 1 1, 3 0s and 2 1s. It worked. It can even work if we did A, B, B, A, such as that, or even that a blue ocean with a triple N at the end. And as you can see, there's a triple N at the end, A space blue space ocean and 3 N's.